NASA is preparing to unveil an exciting new set of images of Comet 3 I/Atlas, an interstellar visitor that has captured international attention due to its rare origin and dramatic behavior as it passed near the Sun. Later today, at 2 p.m. CST, 2000 hours Universal Time Coordinated, NASA will host a live event where astronomers, mission specialists, and viewers around the world will have the opportunity to see these new images collected from several spacecraft and observatories. They are encouraging people not only to watch the live broadcast, but also to join in the conversation by asking questions through the YouTube live chat or posting on social platforms using the hashtag #AskNASA. The excitement surrounding this event reflects the scientific significance of 3 I/Atlas, which is only the third known object from interstellar space to enter and pass through our solar system. Because it comes from beyond our Sun's gravitational influence, every new observation helps scientists learn more about the conditions and processes that shaped planetary systems elsewhere in the galaxy. Even before NASA's official release of the new imagery, skilled astrophotographers such as Michael Yeager, Gerald Riemann, and Enrico Prosperi have been capturing impressive early views of the comet as it emerged from its closest approach to the Sun, which occurred on October 29, 2025. Using powerful telescopes, dark sky locations, and carefully timed exposures, they photographed the comet in the difficult conditions of the brightening pre-dawn sky. They shared these early results on the ICQ Comet Observations page on Facebook, where enthusiasts and astronomers frequently gather to exchange comet images and observational notes. Their photographs reveal multiple jets erupting from the comet's nucleus, spreading outward in different directions and forming a complex, dynamic tail structure. These jets are created when ices inside the comet rapidly heat and vaporize as the object travels close to the Sun, releasing dust and gas into space. The early images show dramatic streaks and diffuse clouds of material surrounding a bright, fuzzy core, demonstrating how profoundly the comet was affected by its solar encounter. According to the photographers, they observed the comet at a low altitude, just 7 to 10 degrees above the horizon, and described how twilight and moonlight interfered with their observations, revealing how challenging but rewarding the experience was. Additional confirmation of the comet's behavior near the Sun came from NOAA's CCUR, one coronagraph aboard the GOES 19 satellite. A coronagraph can block out the bright disk of the Sun, allowing astronomers to observe faint objects and plasma structures near the solar atmosphere. This instrument captured the moment when 3 I/Atlas passed close to the Sun, and a citizen scientist named Worichet Bunplod was the one who first spotted the comet in the satellite imagery. Citizen scientists have increasingly played a crucial role in discovering and tracking comets, and this discovery highlights how public involvement continues to enrich scientific research. As 3 I/Atlas moved farther from the glare of the Sun, it became visible again in the early morning sky for observers equipped with telescopes of at least 8 inches, 20 centimeters, in diameter. Despite its interstellar origin and dramatic activity, the comet is not bright enough to be seen with the unaided eye. Observers must rely on star charts, such as the Finder chart created by astronomer Bob King, known as AstroBob, which shows the comet's predicted path across several constellations. The chart guides skywatchers to the object's location, where they can attempt to identify it by its fuzzy, slightly elongated appearance, rather than a clean pinpoint of starlight. Because interstellar objects follow highly unusual hyperbolic orbits, tracking their position requires precise calculations and constant updates as they move rapidly across the sky. Although 3 I/Atlas is now leaving the solar system, its journey through our neighborhood is far from over. The comet made its closest pass to the Sun on October 29, 2025, but it has not yet reached its closest point to Earth, which will occur around December 19, 2025. Even at its nearest, it will still be extremely far away, about 1.8 astronomical units, or 168 million miles, 270 million kilometers. Far too distant to be visible to the naked eye. Nevertheless, astronomers around the world are eager to observe the object while they still can. Because interstellar comets are so rare, Each one provides a unique opportunity to learn about the chemical composition, structure, and behavior of material formed around other stars. Their ices may contain compounds that do not exist in comets native to our own solar system, offering clues about the diverse environments that exist across the galaxy. Between November 2nd and November 25th, ESA's Jupiter Icy Moons Explorer JUICE spacecraft has also been observing Comet 3 Ice/Atlas with its suite of advanced instruments. Although JUICE is primarily designed to study Jupiter's large icy moons, the spacecraft is equipped with sensitive detectors capable of capturing detailed information about passing comets. Observing 3 Ice/Atlas so soon after its solar encounter is particularly valuable because the comet is expected to be highly active during this period, surrounded by a large halo of vaporizing material and trailing a long, luminous tail. These observations should help scientists analyze the comet's composition, thermal behavior, and rate of outgassing. However, the data collected by JUICE will not be transmitted back to Earth until February 2026 due to the spacecraft's communication schedule and the time needed to process and package its scientific measurements. Once the data arrive, researchers will begin examining it to uncover new information about this rare visitor from deep space. As 3 Ice/Atlas continues outward, it joins a very small group of known interstellar objects that have passed through our solar system. Only 2 others have been confirmed before it: 1 I/Oumuamua, discovered in 2017, and 2 I/Borisov, discovered in 2019. Each of these objects displayed unique characteristics that set them apart from typical solar system comets and asteroids. Oumuamua had an unusual, elongated shape and an unexpected acceleration that puzzled astronomers, while Borisov behaved more like a traditional comet but contained chemical signatures unlike those of most comets in our solar system. Scientists hope that 3 Ice/Atlas will add another piece to this growing puzzle of what interstellar bodies are like and how they form. Although it is now on a trajectory that will eventually carry it out of the solar system forever, its brief passage around the Sun has already provided a wealth of data. The dramatic jets and complex tail features seen in recent photographs indicate that its structure reacted intensely to the sudden heat of the Sun after traveling through the cold darkness of interstellar space for millions of years. Studying how it changed during this encounter can help astronomers understand how comets evolve, how volatile materials behave when suddenly heated, and what these reactions reveal about the comet's internal makeup. Every new observation, from ground-based telescopes, spacecraft instruments, amateur astrophotographers, and NASA's upcoming releases, contributes to a more complete picture of this extraordinary object. For now, skywatchers with the right equipment can attempt to find it in the pre-dawn sky, while scientists eagerly await new data and images. NASA's upcoming release promises to reveal details not visible in amateur photographs, offering new insights into the comet's behavior, jets, nucleus, and surrounding cloud of material. Because interstellar objects are so rare, each new view represents a valuable scientific opportunity. With so many observatories and instruments working together, from Earth's surface to space-based platforms, researchers have a unique chance to study 3 Ice/Atlas in ways that would have been impossible just a decade ago. As it gradually fades and moves farther away, the information gathered during these weeks will remain a critical resource for understanding not only this comet, but also the broader population of icy bodies that originate around distant stars and occasionally wander into our solar system, reminding us of the vast connections that link planetary systems throughout the galaxy.